Somewhere in this image is every human who ever lived, and almost no one in the universe can see us. A spacecraft launched decades ago crossed beyond the outer planets and turned its camera back toward home. What it captured was us, a dot so small it nearly vanished into the background noise of the cosmos. Scientists studying that image understood something most of us never fully grasp about our place in space. To any observer beyond our solar system, our sun is one of hundreds of billions of ordinary stars. And right beside that ordinary star, clinging to it in the dark, is a world full of 8 billion people. Earth is hidden in the shadow of its own star. Subscribe to Noxar Flux so you never miss the stories the universe is trying to hide. From 40 light years away, our entire solar system compresses into a single, undetectable speck of light. Every signal that leaves Earth behaves exactly like those ripples, spreading outward, growing thinner with every mile. With every light year traveled, the signal spreads across a larger and larger surface, becoming impossibly faint. But the signal fading into nothing is only part of the problem, because something far worse is already hiding us. Earth does not glow on its own. It is a dark rock sitting directly beside one of the brightest objects in the sky. Imagine holding a candle beside a spotlight and asking someone 100 meters away to see the candle flame. Our sun is billions of times brighter than everything humanity has ever built or ever transmitted into space. All our cities, all our satellites, all our radio towers produce light that the sun erases without effort. We are not hiding in darkness. We are hiding in the shadow of our own star, which is far more effective. Jupiter and Saturn would actually be far easier for any alien telescope to find because of their enormous size. Even our most advanced telescopes built specifically to find planets struggle to image worlds near their stars. And our telescopes know exactly where to look. An alien civilization searching for us has no such advantage. So before a single alien telescope points our way, something even more fundamental must be understood first. The universe is not quiet. It is filled with electromagnetic noise from billions of stars and exploding supernovae. What we call our radio broadcasts are indistinguishable from this noise, and that boundary has a precise distance. Around a century ago, humanity began sending electromagnetic signals into space for the first time in history. Those first signals left Earth and have been traveling outward at the speed of light ever since, without stopping. 100 years times the speed of light means our oldest signals have now traveled roughly 100 light years. But that signal is now an unimaginably thin, spherical shell of radiation spread across an astronomical area. 40 light years is the distance at which even the strongest signal we ever produced fades into background noise. Beyond 40 light years, our signal can no longer be separated from the natural radiation of the universe. 40 light years is not an arbitrary number. It is the edge of the only zone where we technically exist at all. Imagine calling someone whose location is so far away your voice takes decades to arrive, and arrives as silence. Every known star system within 40 light years is a potential zone where a civilization might have heard us. Within that zone, there are interesting star systems, places we have observed, places that could harbor life. But even within those 40 light years, our signal is already too weak for almost any telescope to detect. A signal sent from Earth reaches a star 40 light years away at a tiny fraction of its original strength. Any civilization trying to detect us would need receivers of a scale we cannot currently imagine or build. It is not just a question of better technology. It is technology operating on an entirely different level of capability. Our signal would look almost identical to natural background radiation to any observer beyond 40 light years. Even with perfect technology, they would need years of continuous focused observation just to confirm our existence. Not a glance, years of uninterrupted monitoring of a single point in an ocean of 300 billion other points. Tell me in the comments whether you think we should be trying harder to signal our existence or stay quiet. And all of this assumes the observer already knows to look at our solar system, which is the real challenge. Our galaxy alone contains an estimated 200 to 400 billion stars, and our sun stands out in none of them. Finding our star among the galaxy would be like finding one specific light in a city of hundreds of billions. But there is one final layer to our invisibility that makes everything else seem small by comparison. Even if a civilization detected us, it would still face the second enormous problem of actually reaching us. 40 light years means 40 years of traveling at the speed of light, the fastest anything in physics can move. With our current technology, that journey would take not decades, but hundreds of thousands of years to complete. Our fastest spacecraft would need more time than human civilization has existed to cover that distance. Physicists studying this problem agree that the barriers are not engineering problems, but fundamental laws of physics.
As any object approaches the speed of light, the energy required to accelerate it further approaches infinity.
And the universe itself is expanding, meaning distant targets are moving away from us even as we would travel. The distance alone is not the barrier. The combination of distance, physics, and time makes it nearly impossible. This is why telescopes remain the only realistic tool for any civilization to observe another at these distances. One method astronomers use is the transit technique, watching for a star's brightness to dip as a planet crosses it. That dip is 13 hours long and occurs once every 365 days. Then it vanishes completely. For an alien civilization to detect that transit, they would first need to know which star to point their telescope at. They would need a reason to single out our sun from 400 billion identical-looking candidates in the galaxy. Our sun has no unusual radiation pattern, no striking brightness, no cosmic feature that would attract any attention. Another method is spectroscopy, analyzing a star's light for chemical signatures that might hint at a nearby planet. Our atmosphere does carry a chemical signature, but detecting it requires already knowing which star to analyze. Without a reason to look at our specific star, all the indirect detection methods in the universe mean nothing.
Even if an alien civilization built telescopes far beyond anything we can currently imagine, this problem remains.
400 billion candidates, each requiring years of focused observation, is not a technology problem.
It is a statistical problem so vast that random chance becomes essentially the only path to discovery.
Angular resolution limits mean that beyond 20 light years, Earth and our sun become impossible to separate optically. Beyond 40 light years, we are not just hard to find. We are physically compressed into a point that cannot be resolved. The wobble method tracks how a star is pulled ever so slightly by the gravity of its orbiting planets. Earth's mass is small. Our gravitational wobble on the sun is real but almost impossible to detect at any distance. Each detection method works in theory, but each requires targeting the right star first, and that is the fundamental barrier. We have been broadcasting for a century, and our signal has already nearly reached the limit of its theoretical range. Imagine being asked to find one specific person on Earth with no name, no location, and no description to guide you. Now multiply that challenge by the number of stars in the Milky Way. That is what finding us requires. We are a needle in a haystack, larger than anything the human mind can genuinely comprehend in full. And unlike the proverb, no one is searching for this needle because no one knows the needle exists at all. We could send a targeted signal toward every star within 40 light years and still wait 40 years for any reply. And that reply would only come if a civilization happened to be listening at exactly the right frequency at the right time. Our most distant physical object has traveled for decades and crossed only an infinitesimal fraction of 40 light years. This is the full picture of our visibility from space, a thinning bubble of whispered signals surrounding a hidden world.
Some scientists argue this invisible status is actually the safest possible situation for a young civilization like ours.
A civilization with the technology to cross 40 light years and reach us would be incomprehensibly more advanced. Our fate in any such encounter would lie entirely in their hands and their intentions toward a younger civilization. Perhaps drifting quietly on our small planet without ever seeing or hearing another civilization is the best outcome. 8 billion people, thousands of years of history, and every signal we have ever sent compressed into invisible silence. We are not invisible because we are too quiet. We are invisible because the universe is too enormous and we are too new. Subscribe to Noxar Flux so you never miss a story. The cosmic mysteries hiding us from the universe drop every week.